So guys, welcome to our channel once again. In today's video we have here 5 questions to answer on the topic chemical combination. So guys, this video will be all about Gay Lussac's law of combining volumes. So in short, stay till the end of this video guys, and then if you feel you want to answer any question here before we provide the answer, guys, you already know what to do at any point. You can always pause this video and try out the answer to the question even before we provide the answer thereafter. So guys, let's start with the first question we have here, and that's question number 1. It says Gay Lussac's law describes the combining A, pressure of gases that react together, B, temperature of gases that react together, C, volume of gases that react together, D, volume and temperature of gases that react together. So guys, the answer to this question is option C, and that's volume of gases that react together. Gay Lussac's law describes the combining volume of gases that react together. So guys, let's check out the next question here, and that's question number 2. It says 150 cm cube of hydrogen is packed with 50 cm cube of oxygen at 100 degrees Celsius and 1 atm. The total volume of the residual gases is A, 100 cm cube, B, 150 cm cube, C, 200 cm cube, D, 50 cm cube. So guys, here we're going to zoom into our workspace here and solve this together. So guys, first of all, like you already know, the first thing we are going to do here is to write the equation of the reaction. So we have 2 of these. There's 2 molecules of hydrogen packed with 1 molecule of oxygen here to yield two molecules of water here. So guys, having this now, we are going to go ahead and solve for this to know the volume of residual gases. But guys, to know the volume of residual gases, we have to know the volume of each of these gases before sparking, on sparking, and after sparking. So we are going to just before sparking, on sparking, and then after sparking. So guys, we're just going to represent this as before sparking, on sparking, and after sparking. So guys, let's draw a line over here to make this uniform. So let's just say this is, here is for hydrogen, here is for oxygen, and here is for the water vapor that was produced. So guys, we know that here 2 moles of this will be sparked with 1 mole of this to yield 2 mole of this. From the reaction we have here, this is 2, and then this is 1 for this, and then this is 2 for this. So guys, having this, we already know that this will be the way the volume will also be distributed. So let's first of all consider the volume before sparking. So the volume of hydrogen before sparking will correspond with the volume of hydrogen that was given to us, guys. 150 cm cube of hydrogen are sparked, so that means the volume of hydrogen before sparking is 150 cm cube. So we're going to write 150 here. Then it was sparked with 50 cm cube of oxygen, so that of oxygen is 50 cm cube. So guys, for water before sparking there was no reaction, so which means before sparking water was 0 or nil, so that will be nothing here. So that makes sense because the product came when we've already sparked the hydrogen with the oxygen. So guys, that's why we have 0 here. So on the next step now, we are going to check out their volumes on sparking. So guys, on sparking we require 2 of these and 1 of these, then 2 of these. So guys, with this we are going to start with the volume of oxygen here, because that's the smallest here. So oxygen that was used in this process was just 50 cm cube. So guys, for hydrogen that was used on sparking, that was 2 times the volume of oxygen, since you have 2 here and 1 here, so that's 2 times the volume of oxygen. So guys, that's 100 cm cube. And then for the water yielded on sparking, that will be 100 again. So the water produced on sparking is 100 as well. So here, after sparking, what's the volume remaining after sparking? So guys, for us to find the volume after sparking, we are just going to take the difference between the volumes before sparking and the volumes on sparking. So the difference between 150 and 100 is 50, guys. So the difference between 50 and 50 is 0, and then the difference between 0 and 100 here is 100. So guys, that's it here. So since we have 0 oxygen after sparking, and then 50 of the hydrogen gas after sparking, and 100 of the water gas, that's water vapor, after sparking. So guys, the volumes of the residual gases will be this 50 cm cube of hydrogen plus the 100 cm cube of the water vapor. So guys, we're going to add this together, and then that's the residual gas. That's 50 plus 100, and guys, that's 150. So guys, that's the answer to this question, and that's option B, guys. So let's go ahead and wipe this, and then let's consider the next question. So guys, the next question here is question number 3. It says, okay, we have an equation of a reaction here, and then the question says, in the reaction above, what volume of hydrogen would be left over when 300 cm cube of oxygen and 1000 cm cube of hydrogen are exploded in a sealed tube? So guys, let's zoom in right here to our workspace, and then let's try to solve this together. So we'll first of all write the equation of the reaction as always. So we'll have H2, 2H2 gas plus O2 gas to yield 2H2O gas, 2H2 gas, 2H2O gas. So guys, having written this equation of the reaction, the next thing we are going to do is to state out the ratio here. So this is in the ratio 2:1 is to 2. So guys, having stated that the ratio here, we have to understand the combining volumes. So they said in the reaction above, what volume of hydrogen would be left over when 300 cm cube of oxygen and 1000 cm cube of hydrogen are exploded in a sealed tube? So guys, 300 cm cube of oxygen was used here. So guys, remember, we always want to start with the smaller volume so that we will know the volume of the larger one that will be left. So guys, if 300 cm cube of oxygen is used in this reaction, what will be the volume of hydrogen that will be used up in this reaction? So guys, it will be 300 times 2, since this is in the ratio of 2:1 here. So guys, that means 300 times 2 is 600. So it means 600 cm cube of hydrogen was used, and 300 cm cube of oxygen was used, and then 600 cm cube of water gas, that's water vapor, was produced, because this is in the ratio 2 here is to 2 here. So if 600 was produced here, it means 600 was also produced here. then if 600 was produced here, 300 was produced here, or if 300 was produced here, 600 was produced here. So guys, having this, we know that we used 1000 cm cube, guys. So 1000 cm cube that was used in the reaction minus 600 cm cube that's reacted. So guys, that would be 400 here, 400 cm cube. So guys, the correct answer to this question here is option A, and that's 400 cm cube. So let's go ahead and wipe this off, and then let's check out the next question. So guys, the next question here is question number 4. It says, what volume of oxygen will remain after reacting 8 cm cube of hydrogen with 20 cm cube of oxygen? So guys, the reaction between hydrogen and oxygen can be represented to us. So let's zoom in to our workspace here. Again, we'll start with 2H2, then plus O2 to yield 2H2O. So guys, already we know that the ratio will be 2:1:2 here. Having known this, we said what volume of oxygen will remain after reacting 8 cm cube of hydrogen with 20 cm cube of oxygen. So guys, we are simply going to write this down here. 8 cm cube of this will require, since this is in the ratio 2:1, so this will require half of this. So half of 8 is 4 cm cube here, and then this will be 8 cm cube. So guys, if 4 cm cube of oxygen will only react here, it means out of the 20 cm cube, we'll have 20 minus 4 to give us 16 cm cube. So guys, the volume of oxygen that will remain in this reaction will be 16 cm cube of oxygen. So guys, that's option D here. So let's wipe this off, and then let's consider the next question, guys. And that's question number 5. So guys, the next question here says, according to Gay Lussac's law, if the temperature of a gas is halved while keeping the volume and amount constant, what happens to the pressure? A, it remains the same. B, it quadruples. C, it doubles. D, it halves. So guys, the answer to this question is option D, and that's it halves. According to Gay Lussac's law, the pressure of a gas is directly proportional to the absolute temperature, provided the volume remains constant. So guys, if the temperature of a gas is halved while keeping the volume and amount constant, the pressure will also be halved. So guys, that's the answer to this question, and that's option D here. So this is where we'll end the video, guys, for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. We also want to encourage you to join our YouTube channel community. So guys, thank you for watching this video, and see you in the next one.